Many of you still need exponent practice. This one over here, simplify everywhere you can. You should recognize that the top is b to the what? 6. And the bottom is 2b to the what? 7. What do you do with 6 of those b's? Cancel them out. So there's only 1. How many b's are left on the bottom after I've got rid of 6 of them? 1. 1 over 2b1. Do we ever write 1 as an exponent? So it's 1 over 2b. C for a second mark. Over here. Should I worry about that negative 2 right now? Why? What might happen to it? It might take care of itself. So when should I leave my negative exponents? Till the end if I can. So on the bottom here, is there anything I can do right away? I can deal with that, can't I? What does it become? Negative 12, yes? Then what can I do with the negative 2 and the negative 12? Add them. So I get 2k to the negative 2 over 2k to the negative 14, yes? Okay, what happens to those 2's? They cancel? What happens to those 2's? He waited patiently. Somebody already said they cancel, but what does that mean? You divide them. 2 divided by 2 is 1, so they're gone away. Do I write any zeros? No, because they're not gone. It's just division. What do I do here? So what's negative 2 minus negative 14? Positive 12. Did my negatives take care of themselves? So what's my answer? A. That's the first one I would expect people to have some questions about. Is everyone okay with it? Okay, what do I do with 4? What do I take care of first? Right there. What does that become? Negative 4. What do I do with 4 and negative 4? It becomes p to the 0, which is what? What is anything to the 0 power? 1. So this becomes 2p cubed over 1. Do I ever write divided by 1? So what's the answer? 2p cubed, A. I like that question because a great many of you lawyer ball yourself out of the answer. Because you don't actually stop when you can stop. You think there is more to it, which is almost worse than not knowing how to do it at all. What about 5? So I've got x to the 4th. Where does that 3 go? Everything. So the 2 becomes what? 2 cubed. The x cubed becomes what? X to the 9th. And then there's x to the what? 1. What do I do with that 9 and 1? What do I do with that 2 cubed? 8. X to the 10th. What do I do with 4 of them? Those 4 are gone. I got rid of 4 of these, so how many are left? 6. So what's the answer? 1 over 8x6, right there, D. How many people improved over their first quiz on the front page? Good. I didn't put the first quiz in to check my mark, I don't think. I did? Okay. 96 is what? 16 times 6. What's the square root of 16? 4 root 6. Could you have gotten to it in another way? Do I care how you got to it? No. As long as you got, I've been trying to talk long enough for the answer to show up here because I wrote it a while ago. That's why I did extra words there. It still hasn't shown up, and I'm still talking. I'm going to keep... There it is. As long as you got that, do I care how you got to it? No. Are you ever in the 10th grade going to be giving me a decimal answer for an irrational square root? No. I have said that 1,000 times, and yet on the last quiz, I saw people handing me in answers that were decimals. This one, 9 and 5, so it's 3 root 5. Do I care how you got there? No. This one, 16 and 2, so it's 4 root 2. This one, 16 and 5, yeah? What's the square root of 16? So what comes out? What was already there? So it's 24 root 5. What about this one? 7 and 21. 21 break down again? 7 and 3. Is there a group of 2? So what comes out? 7. What was already out? So it's negative 56 root 3. 25 times 3. What comes out? 5. What was already out? So it's 10 root 3. Now we get to the snaky stuff. If that's not there, do you know how to do it? The letters. If the number's not there, do you know how to do it? Yeah, you do. If the number isn't there and it's just that, do you know what to do? How big a group am I looking for? 2. How many A's are under there? 4. So how many groups 2 can I get out? 2. So you do know how to do it. So, first thing we deal with is a number, which happens to be 7 times 49, yeah? Why do I stop there? 49 is a perfect square, so what comes out? 7. What did I leave under there? 7. I took out the 49. How many A's can I get out of there? If I am bad at learning the shortcut here, but I remember Mr. Myers said, oh yeah, Myers said if we wrote it out, we'd always be able to figure out. So a to the 4th and b squared must be a. And b squared must be bb. Is there a group of 2? So what comes out? A. Is there a group of 2? So what comes out? Another A. Is there a group of 2? So what comes out? B. So I got 7 times negative 7, which is negative 49. A times A, which is A squared. B. And what did I leave under there? Just a 7. Once again, I am telling you that if you actually learn the concept, you can always do the math. But if you refuse to learn the concept, you only want to learn the shortcut, then actually pay attention and learn the shortcuts. This guy, what should I deal with first? The number, it's 2 times 64. Why do I stop there? 64 is a perfect square, so what's coming out? 8. How many U's are coming out? 1. How many U's did I leave in there? 1. So I took out 2 of them, I left 1. How many V's are coming out? 2. Plus there was a negative 5 out there. What did I leave under there? 2U. 8 times negative 5 is negative 40. U, V squared root 2U. This is the hardest thing for kids. For some reason, this concept boggles your minds. Not all of you, but a great many of you. Even though you all know that there's supposed to be a little 2 there, you all understand you're looking for groups of 2. But you don't get that if you take them out of there, that you have to leave the remainders in there. Okay. And finally, 32 is 16 times 2. I stop there. Why? 16 is a perfect square, so what comes out? 4. How many a's can I get out? 2. A squared, then a negative 5. Can I get any b's out? No. So what stayed under there? 2b. And what did this become? Negative 20a squared root 2b. Or is it not 2b? No, it doesn't. Every math teacher makes that joke whenever they get to write 2b. So give yourself a mark out of 14. How many people improved? How many people stayed the same? Did anybody go down? Good. Listen, please. Listen, please. Later in today's class, when I'm letting you work, I'll come around and I'll get the new mark and I'll put it in for the old one. Okay? Okay. I left you guys work with Mr. or Ms. Substitute. It was a Mr. again?
Yeah, there's like it was Mr. Como and then there was like a principal, a vice principal, and Mr.
Miss Webster?
Webster, and then Mr. Abraham.
Wow. You guys partied down. Okay, did it start with you guys? Were you guys first block Friday?
Yeah.
Oh, that's why. Okay.
No, Mr. T was here the first day.
Yes. Okay. So you guys had 102 and 103, which I have answers for right here. Please check your work over. I will highlight the answers. Oops. So there's 1, 2, 3, 4, 5, 6, 7. Actually, I lied. Number 6 is not. It is that. There. Any questions about 1, 2, 3, 4, 5, 6, 7? Answers are all highlighted. Haley. Number 6. Yes, I can. Anything from before 6? Once, twice, thrice? Okay, now, I didn't specifically show you a situation like number 6, did I? But we did talk about that in our notes right here. Wake up. Wake up. So right here, right? We distributed, yeah? So looking at number 6 there, we're going to distribute it. I'm going to use the red arrow to do the first distribution. How do I multiply 2 root 3 times 2 root 7? Coefficients first, so it's 2 times 2, which is 4. And then the radicand, 7 times 3, which is what? 21. Now, can I simplify that? No pairs, because it's 3 times 7, right? Then I do the same thing again. Minus coefficients. What's 2 times 4? 8. 3 times 5? 15. Can I simplify that? No. Now, I told you guys that this is the exact same thing as 4x minus 8y, right? Can I put them together? No, because they're not like terms. So can I put them together? No, because they're not like terms. So it stays right there. Everybody okay? All right. And then this one. Cool. Everyone's good up to 7? All right. 7 right there. And there is 8, 9, 10. 11. But it's frozen a little. I can't go back up high enough right now. There is 8, 9, 10. Final answers are highlighted in blue. Everything in yellow is pre-simplified. So, going on what we've been talking about lately, if you got to the yellow point, then happy, right? That's the 2 or the 3, meeting expectations, right? You've multiplied radicals there. This is my exceeding, yay, but it's not really, because this is what I really expect of you. But since they're going to force me to do meeting and exceeding expectations very soon, I'm starting to warm you guys up to it now. Does anybody need to talk about 8, 9, 10, or 11? Going once. Going twice. Going thrice. We are good? Excellent. And then just to remind you, 103, I had some simplifying on there. There's 1 through 8. Answers highlighted. Please check your work. Everyone is good? Please do not copy down the right answers. This is being recorded. If you didn't do it, you can check it later. And there is 9 through to the end. That one is the right answer. Does anybody need 9 through 13 discussed? Once, twice, thrice. Say when. Okay. Please open your books to, I believe it is 104. Should say fractional exponents, one of my favorite fonts. All right. Remember how I said that if you actually understand the concept and you write the stuff out, you can always do it, right? And then we bumped into negative exponents. And knowing the concept didn't really help, but then when we drew it out and we made that chart, oh, okay, obviously that would be how it works, yes? All right. Rational exponents, and I write fractional, even though that's not the proper word for it. That's what you guys are going to say. What really this should say is rational exponents. But I use fractional because it's easier for you guys to remember. To do this one, it's really hard to explain with the concept. So we're going to do something a little different than we usually do. And everyone's going to get out their calculators. Hopefully it's in front of you right now. All of you are going to do the following. You're going to hit the button marked 9. 9. Then you are going to hit your exponent button. So it might be the mountain, it might be x to the y, it might be y to the x. I don't care. Hit that button that you use to make an exponent. Everybody has done that, yes? Now, then I want you to do what I'm about to do. I don't want you to do a shortcut that you think will be helpful to you. I want you to hit the first bracket, 1 divided by 2, and close the bracket. And then push equals. And tell me what you get. What do you get? 3. Now I want you to do that for all 3 of these. So this one's going to be 27, exponent button, 1 divided by 3. 625, exponent button, 1 divided by 4. And tell me what you get. 3 and 5. Right? Right? Okay. Now, a great many of you either already know what I'm about to say, or just by looking at that have probably figured out what I'm about to say. Is there a relationship between 3, 9, and some kind of exponent? Right. That's the answer that I'm looking for. Rihanna says, okay, yeah, 3 squared equals 9. Yes? Now, is there some kind of relationship between 9 and 3 that deals with exponents in some way? Right. Rihanna said it again. Rihanna said the square root of 9 is 3. Yes? Everybody's cool? So now let's look at something logically here. If the square root of 9, and I have to wait till my computer thaws, if the square root of 9 equals 3, and 9 to the 1/2 equals 3, then what do we know about 9 to the 1/2 and the square root of 9? That they are the same thing, aren't they? Because if they both equal 3, then they must equal each other, yes? Now I'm going to do something, like I said, every so often I do stuff for you guys that is a little bit cheaty. This is one of those times. What number should be written here? 2. What exponent should 9 really have that we don't write? 1. Do you see what you need to do here? That became the denominator. The numerator, that became the denominator. Now look here. Is there a relationship between 3, 27, and an exponent? 3 cubed is 27, yes? Which means the cube root of 27 must be 3, yes? Right? And 27 to the 1/3 must be 3, yes? Because of what we just found out from our calculator. So what can we really put in the middle here? Just the 1 equals sign. Is everybody cool? So what would this one be? Instead of 625 to the 1/4, how can I write it in a different way? Look at what I did here. Look at what I did here. What can I do here? 5 to the 4th equals 625, right? Which means that the fourth root of 625 equals 5, yes? But, as we just found out, 5 also equals 625 to the 1/4. So what can I do with the middle here? I can get rid of it and just write the 1 equals sign, because the denominator, 4, became the index. The numerator, 1, became the power of the radicand. Does everyone see that? Okay, so now I want to put this into general terms, terms that will work with any number. So let's write it out. X to the a over b. It's almost a new exponent law. That equals the b root of x to the a power. Does everybody understand? The numbers just move around, and this is why it works. Is everyone cool? All right. So my book did a weird printing thing. Did your guys' do that too? Put A and B right mashed together like that? Okay. So here's what I want for you to do. I'm just going to erase B here. I'm going to write it down here. It's 27 to the 4/3, yes? And then everything's good. So, knowing what we know, does this, even though it's a decimal and yucky, look very similar to this? It's a base with an exponent, yeah? The denominator of the exponent becomes the index. So it's a square root, yes? Of what? 0.04, right? Which is the same as 4 over 100, correct? Everybody with me? And all of that is to what power? 3. What is the square root of 4? 2. What is the square root of 100? 10. And all of that is to what power? 3. Where does that 3 go when I have a fraction? Everywhere. So 2 cubed becomes what? 8 over 10 cubed becomes what? 1,000. Yes? Can I leave the answer that way? You could simplify it to what? Two 1/25ths, right? Or 0.008. Is everybody good? You would simplify that to either 2 over 125, right? I lie. 1 over 125. 2 over 250. Blah, blah, blah. Everyone is good? All right, let's look at B. Does B look exactly like this? Is it a base to a rational exponent? Yes. So the denominator becomes what? The index. Square root, what goes under there? The base. And all that is to what power? 4. What is the cubed root of 27? 3 to the 4th power. What is 3 to the 4th power? You don't need to go to your calculator. What's 3 times 3?
9.
And what's 3 times 3? 9. What's 9 times 9?
81.
81. Everybody cool? does C look like this right now? No, because there's extra exponents there, right? Oh, but Meyer says everything we've ever done I need to know now. Oh, I know what to do over brackets. What do I do? Multiply. What's 1/3 times 2? One calculator times 2 is 2 calculators. So 1/3 times 2 is 2/3. Thank you, Robert. I'm going to pretend he said 2/3 because that's what I heard. Now, does this look like this? So what do I do? I take the cubed root of what? 8, and then I do what with it? Not multiply it by 2. Square it. What is the cubed root of 8? 2 squared. What is 2 squared? 4. Now, whoever said multiply by 2 is going to say, that's what you did. And you're right, it happened to work out here. But it won't always. That's why I stress that you have to square it, not multiply by 2. Now, please notice, what does that instruction say? Which means this is quite doable without a calculator, isn't it? Why? Because what is 0.49 really? 49 over 100. And all of that is to the 1/2. Does that look like our example? So the 2 becomes the index. The base becomes the radicand. And the 1 becomes the power, correct? Okay. What's the square root of 49? 7. What's the square root of 100? 10. And all that is to the first power. So does it change? Does it change? No. Can I leave it like that? Sure. That makes me happy. That's the right answer. But is it also 0.7? Yes. Everybody good? Look at E. What's weird about E? It's got a decimal instead of a fraction. We know how to convert that though, don't we? What is 1.5 as a fraction? That's 1.5. What's that? 3 over 2. So isn't this 16 to the 3/2? Now does that look like our example? So what do? I take the square root of 16 and I square it? Cube it. What is the square root of 16? 4 cubed. What's 4 cubed? 64. Now, you guys have all the tools you need to figure out F. Go. Look at what's ugly about it. Think of what you can do to change that into something you recognize. Then do it and see what happens. So, what did you not like about F? Decimal. I don't like 0.75. So what is it really? 3/4. Now what? 4th root of 81 cubed, yes? Now let's pretend we just didn't do the 4th root of 81, because we just did. It's right here, isn't it? We just did it 2 questions ago. Some of you won't make that connection. So you come back here and say 4th root of 81. Oh, okay, so let's break that down. That's 9 times 9. There's no group of 4 there. 3 times 3 and 3. Oh, there's my group of 4. So what comes out? 3. Did I leave anything under there?
No.
So I cube 3, and what do I get? 27. Is everybody good? What have you noticed about every question we have done up till now? Same concept, and it's worked out perfectly, hasn't it? We've been able to do them in our head. That's a new sound. In the real world, if you are actually doing math in the real world, not math in math class, is it always going to work out? No. Sometimes your numbers are not going to work out. Because what does this really mean? It means the 5th root of what number? 8 squared, yes? Does 8 have a 5th root? No, the biggest root 8 has the 3rd root, correct? 2 times 2 times 2. So when you get to a problem where you cannot do it because 8 has no 5th root, you must use your calculator. So this is a very physicsy type question. And we already know how to do that with our calculator. What would we punch in? We did it up at the top when we were proving this. It's still base, exponent button, bracket, A divided by B. Because that is A and that is B in our example, yes? So this question would be 2 divided by 5. Close the bracket. And everybody would punch that in. And what will you get? A barfy decimal. Right? What do you get when you do that? Blech. Is it rational? No. So we round it off. Do I care? I don't care where you round it off to. Some of you are going to round that to 2.30. Some of you are going to round it to 2.3. Some of you are going to round it to 2.97 because that 3 is the first place that it doesn't bump up the next number. Do you follow me? If I were faced with this, I would not ask my teacher what you wanted me to round to, teacher. I would just round to 2.97 because that's the spot where you can stop rounding. Do you understand what I'm saying? The 9 bumps up the 3, the 7 bumps up the 9, but the 3 doesn't bump up anything. So I would take that to 2.97 if I were a math student in the 9th grade, or 2.297, sorry. Now, can I say officially that it equals that? If I was being a real mean teacher and you wrote equals, can I actually give you a full 100% happy face mark there? Yes or no? No. Why? Because it would actually equal that. It doesn't, does it? That's my rounding. So remember I showed you that little zip, you give it the squiggly equal sign. That says to me that you know that you have rounded that off. All right? And it's useful in working with bigger questions later on. Because we had that in the first unit. Yes, people rounded it at weird places and everybody got slightly different answers, right? You hand your work in to me and I see that symbol there, I know you've done some rounding in a weird spot. So if you get a weird answer, oh, I see, they rounded in the second step there. Okay, I understand what's going on. Everybody with me? It's something there for you guys. So how would I punch that into my calculator? I'd still use base, exponent, bracket, bracket. So what would I do? I'd punch in 0.6, exponent, bracket, 15, divided by 7. And what would I get for an answer? Bleh. Where could you round it to? You could leave it as 0.3. I'd be happy. 0.33. You could even go 0.335. I would be happy with all of that. Just remember, it's approximately. It's like 0.335, right? Everybody cool? In math class, your teachers are generally nice. They want you to be able to work it out. In science, you can't do that. So let's look at this question right here. That gives me a formula, yes? All right. So let's use that. B is the brain mass, and M is the mass of the animal. So I'm going to use this formula to find out the mass of my dog's brain. Let's see if it works. B equals what? 0.01 times what? 27 to what power? 2/3. So it's easy to write down, right? But some of you are going to have calculators that makes this really difficult. Everybody punch that in the way they think it should be. And then I'm going to ask for a few different answers. What do we got for some answers, people? Is that an answer somebody got? Still waiting. Did anybody get a different answer than Robert? Or Carlin, I mean. Everybody got 0.09? Sweet. That means everyone's doing it right. So what's the polar bear going to be? What do we got? 0.34, just fine. Yep. Oh, nice. Rounded. Excellent. And what about C? What do we get? 0.15. Yay! Everyone can use their calculators even. All right. So now you can use your calculators to do real life science questions, and you can use your brains to do math class questions. Let's go on to, you guys are going to do page 106 there. Go diddly O. Wait, one sec. Actually, no. Let's not quite do that. Let's go to 108 first. Do these things look weird? They look weird. But do looks matter? No, we're going to follow simple concepts that we already know. What do you notice about that and that? They're the same base. So do we know something about that? What do we know? Add the exponents. What's negative 3 and 5? 0.3 squared, yes? Right? What is 0.3 really? 3 over 10. 3 over 10 squared. 9/100ths, which is 0.09. Simplified without a calculator, yes? How many of you look at 2 and immediately go, yikes? Be honest. 2 looks utterly frightening, doesn't it? What do you notice about that and that? They're the same base. So isn't this the exact same as x to the negative 4 squared and x squared cubed? Isn't it? You know what to do with that. What would you do over the brackets? What would you do over the brackets? Multiply, so you'd get x to the negative 8, wouldn't you? What would you do right there? Multiply, so you'd get x to the what? 6, right? Then what would you do with those? I'd add them to get x to the what? Negative 2, correct? Am I at the end? What does, well, I've got to deal with this negative exponent now, don't I? This x should be x over 1, shouldn't it? So that negative exponent would flip it, right? So this would become, I'd flip that over to be 1 over x squared, yes? Which would get me 1 over x squared. Everyone agrees? Well, all I did right there when I flipped the fraction, my fraction was negative 3/2, wasn't it? So what happens when we flip it? It becomes what? Negative 2/3 squared, yes? And now it's super easy. What's negative 2 squared? Positive 4. And what's 3 squared?
Oh no, 9.
Did everybody see that handy little trick? Are you allowed to do that? Yes, because it makes your life easier. Is this question scary? Sort of, but not like that. Fractions make us all pee our pants a little bit. Is there any need to? No. What do I notice about that, and that? Same base. So what can I do with the exponents? All my usual laws, right? What's the top? 1.4 to the what? (1.4 to the what? 7 over. What do I do with those? Right, what's 7 minus 2? 9. Is that simplified? Sure, because I did say no calculator, right? I can't do that in my head, can you? So we're going to leave it like that. Does 4 scare you? Shouldn't, because why? Same bases. So I've got 7 to the 2/3 up top, and what have I got on the bottom? 6/3. Hey, wait a minute. 6/3? What's that? That's 2, isn't it? 7 to the 2/3 over 7 squared. Okay, what do I do here? Subtract. Well, I know that 2 is 6/3, right? Well, what's 2 take away 6? 7 to the negative 4/3, isn't it? Is that allowed? What do I do? What should this really be over? So what do I do? Flip it to 1 over 7 to what power? Positive 4/3. Can I leave it like that, or is there another way I could write it? What can I do with that exponent? We just did it. What does the denominator become? Index. What does the base become? The radicand. What does the numerator become? The power. Are these the exact same thing? That one is exponential form. That one is radical form. Do I care? Do I care which you show me? If I did care, would I tell you which one to show me? Yes. Look at 5. Looks weird, right? What else does that one work with? The other x. If there were no y's there, I would have x to the what power? If there were no y's there, I would have x to what power? 5. If there were no x's there, what would I do with the y's? Okay, so what would it be? -2. Is that allowed? What part of that is not allowed? Just this one, yes? Is this guy okay? So how do we fix that? Does the x have to move? No. But y has to move. And what will y become? Positive. Cool? Now, in 6, mine doesn't have the a. Does yours? It's supposed to have an a there. So, if there were no variables, what would be the answer in number 6? 2. If there was no 10 and 5 and no b's, what would the a's be? 2. And if there was no 10 and 5 and no a's, what would the b's be? Which is it? 5. Are we happy with that? Is everything positive? Is all the division taken care of? So are we happy with it? Excellent. Okay. I am going to shut my pie hole. And I'm going to suggest for you page 106, which if you follow along in your outline is called page 227. And I want you to finish 109 to 110. And I am going to choose to believe you. Page 111 here. Listen to me, please, guys. These 2 pages so for you guys, page 111 and page 112, I cannot stress this enough. You're not as comfortable with exponents and radicals as you think you are. Do you understand what I'm saying? So I recommend you give a good look at the pages entitled 233 and 241. I would give them a real solid look, at least. Like I would make sure I could do a question or two out of every section. Maybe you don't need to do all of them, but I would check and make sure that I'm doing like 10G right. Do you understand what I'm saying? The reason I'm not actually assigning it as any kind of work and saying I'm going to come around and check is some of you have this. And if you have it, doing it another 100 times isn't necessary. But some of you need a little bit more practice. Some of you only need 1 or 2 more questions to get it in your head. Some of you need 10. All right? That's what these pages are there for. Some days, it's your only chance to do it, right? But in this unit, we've been doing a crap load of practice as notes. And most people seem okay. But I need you to be actually okay. And the only way you will know if you're okay is if you can actually do some of this stuff without me right here and without your neighbor right here. You understand what I'm saying? So you use as much or as little of pages 233 and 241 as you need. Okay? I'm not going to come around and check it over. But make sure you give this page, page 227, I want that actually done. Do you understand what I'm saying? Because that's the new stuff we just did today. That's the fraction, the rational exponents. Okay? This I want you to do. For you guys, it's page 106. Yep, I'm going to be walking around getting scores for that last quiz and changing what your previous score was. If you know.
I need to go down the crossroads. I've been waiting for you to finish talking so I can ask you.
Okay.